Honorable Prime Minister, ministers, ladies and gentlemen, it's wonderful to be back in Tallinn. We had a wonderful summit last year, and thank you for hosting that, as well as this summit. I'm going to focus my remarks on how to think about the promise and the challenge associated with these technologies that we're talking about, specifically AI. And I'm also going to touch on some of the challenges that we have to deal with. And in the end, I'm going to try and conclude with some imperatives that I think are important for leaders, both in the public sector and business, to think about as we try and make sure that we end up with beneficial outcomes for all of society. Greg took you through a fascinating tour of where we are, where we're going, and what these technologies and tools can now do. I can tell you, when I was a graduate student 20 years ago doing my PhD in AI and robotics, I never imagined we'd be where we are today. It's been truly a remarkable journey. But I think for the purpose of this conversation, I want to recap the picture that I think Greg had, which showed artificial intelligence, robotics, machine learning, and all of these tools. And I think for the purposes of my remarks today, I'm going to take that whole picture, partly because a lot of those systems have somewhat similar and related economic and business impacts. So I'm going to treat Greg's picture in its entirety. And I'm also glad that we're going to have Jack go after this, because Jack has been trying to figure out how we actually measure these things and what the progress we're making. But let me recap a couple of things that Greg said, and I'll put a slight twist on it. Much of the progress that we've seen over the last few years come down, at least in economic terms, to a few specific things. Greg talked about the algorithms, they're much better. We're starting to use them in clever ways. We now have massively more compute capacity, both at the silicon level, but also at the cloud and cluster level. And we've also got much more data that's available to train the algorithms. It's also important to highlight the fourth point here, which is slightly different than Greg's fourth point, but it's one that captures the fact that in many cases, we now are able to combine these systems into useful things. And a driverless car is a good example of a system-level innovation where we've got navigation, algorithms, robotics, machine learning, all of those things coming together to create an intelligent, interesting system. It's also worth noting that, in fact, even with all the progress that we've made, there's still some technical challenges we have to deal with. We have to deal with the fact that sometimes we don't always have data available. Even if we have it, sometimes it's not labeled. Greg talked about supervised learning and also the promise of unsupervised learning. Sometimes we also have to deal with the fact that it's very hard to deal with explainability when it comes to these systems. To be able to pinpoint exactly which factor, which data set led to a prediction or decision. And that's important in some of these applications, particularly when you think about applications that have social implications. Think about when we start to use these systems in our criminal justice system, where we actually have to be able to explain why it is we made the decisions that we made. There are also questions that have come up to do with bias and the use of data samples and so forth that can lead to some weird results coming out of these systems. But the good thing is that all of these kind of challenges are things that I think we're making progress on, and day by day, there's progress being made to actually address these challenges. But let me turn to some of the economic questions and the business questions. One of the things that's quite fascinating is that and we've been building kind of libraries of these things, just watching the huge number of use cases of AI being useful. We can certainly see a lot of the, if you like, consumer applications. But there are also a lot of business applications where these systems and these techniques are now being used to solve business problems, whether it's to do with prediction, forecasting, or even generating new techniques to discover new solutions. And we see these use cases, and there are hundreds of them across all sectors of the economy. So this isn't just confined to one part of the economy or another. And that's actually an important point. It's also important to note that these techniques, even within a given business or a company, are actually quite applicable to different parts of that company, whether it's the sales and marketing parts of the business, or whether it's the operations and supply chain management. We're finding use cases across all the functions in any of these businesses, and that's actually quite important. It's also important to notice that as these use cases and techniques start to get applied, the motivation is not just to replace labor. And that's actually quite important. In many of these cases, the motivation is because the technique itself is providing a solution that's actually better or even beyond what a human might be able to do. And you often see this, for example, in cases like, say, in pharmaceutical industry, where you're trying to play with drug discovery and you're trying to do protein folding, for example. Many of the spaces you're able to explore actually go far in excess of what humans might be able to do. So the motivation is not just to replace labor or substitute for labor, but actually in some cases go beyond. Now, when we think about the impacts of this on the economy beyond business, we think that these are going to have a profound impact. And the impact on the economy mostly comes through thinking through productivity and contributions to economic growth. In many of the simulations and analysis that have been done, and this is just one of them, what you find is that there's a big contribution that comes from labor productivity through substitution and augmentation of work. We'll come back to that topic later in my remarks. But the bigger contribution, as you can see here, comes from innovation and innovation effects, where companies and businesses in the economy are now able to create new products and services or even improve existing products and services to yield to actually more interesting results. Now, of course, some of this gets competed away, given the fact that whenever you have innovation cycles, you have competition and so forth. And in addition, we also need to take into account some of the transition supports and that we're going to have to deal with, mostly to do with some of the labor effects and so forth, which I'll come back to later. But in most of these simulations, the net of this is overwhelmingly positive. And in fact, some even have more aspirational analyses that suggest that these numbers could be even bigger than I'm suggesting here. And so when you think about these contributions, they're particularly important when it comes to productivity, because we know that at the moment, we're seeing sluggish productivity in most advanced economies. And this issue is going to become even more important in the next 50, because most advanced economies are going to have a down drag that comes from aging. So the question of productivity contributions is important, not just now, but in the next 50 years for most advanced economies. And through various assessments that we and others have done, I think in most cases there's a sense that the productivity contributions from these technologies are quite substantial and are going to be a big part of contributing to what actually happens next. So at least at this point, it seems to be clear that this is good for business, certainly good for the economy. But we also want to add that we think it's probably a positive also for society in the sense of helping us to tackle some of society's challenges. Greg outlined some of the things we're now able to do with mapping the brain, and we think these techniques might even help us tackle some of the research in climate science. But even before you get to those kind of breakthrough moonshot societal benefits, we find a lot of applications that are quite useful for many of the challenges that the world is framed, such as the United Nations SDGs, for example. And we've been also, again, building libraries and observing the numerous number of case studies and use cases that are where these techniques are quite helpful tackling today's promising problems, whether it's contributing to medical diagnosis in poor countries, some of the nutritional questions, learning questions. So already we can see these contributions starting to show up in use cases, even in some of the world's most pressing challenges. Now, of course, it's important to point out that in many of these cases, the ability of every part of the world and economy to take advantage of these societal solutions relies on having access to things like data, which in many cases often in the hands of governments or companies who want to monetize it, but also even the challenge of talent that we have to deal with. One of the things that we should point out, though, and this applies to both business, societal challenges, but also to the economy, is that we're seeing quite uneven adoption of these techniques. In business, we've done surveys, and you find that some companies are much, much further ahead in adopting these techniques and starting to deploy them. You find the same thing with economic sectors. Some sectors are much, much more digitized and are moving ahead in capturing and deploying these techniques. We find the same thing even with countries. And in fact, at the country level, it's quite interesting that if you kind of look at different countries, there are clearly two that are way ahead of everybody so far in terms of the investments, the intensity, the scale of research and activity that has to do with artificial intelligence, as well as the related digital technologies. That's the United States and China. There's clearly a second group here that's obviously has a long history of innovation and investments and is doing the same. The difference is really a question of scale and intensity between group 1 and group 2. Then you've got other groups, group C and D here, that are much further behind. The reason this is important is very similar to both companies as well as economies, is that we know that the leaders can quickly get the benefits of these techniques and can quickly get the cumulative, if you like, leadership and stride out ahead of everybody else. And so we must think about this question of how do we make sure that everybody participates and everybody's part of this journey? And I think there's some important questions that we'll need to come back to perhaps discuss at this forum. So if all of this is to say, so far at least, good for business, good for the economy, good for society, but some work to do, the big question on everybody's mind is what about work? Which tends to be one of the big questions. At this forum last year, I described some of the research we've been doing looking at activities, because quite often, I think most of you have come to the conclusion that when you're examining these questions about work, it's much better to start from the level of activities that people do and think about what's now possible to automate versus not, as opposed to try to make kind of top-down decisions. And what we typically find is that if you look across different occupations, this picture just shows each of these dots is an occupation. On the vertical axis, you see, if you like, if an occupation is higher up on the vertical scale, it simply means that the constituent activities that make up that occupation are relatively easy to automate using currently demonstrated technologies. If you're lower down, it means there are fewer of those. And then the horizontal axis just simply shows the wage scale. What you see here is that this has got very little to do with wages and a lot to do with the nature of the activities involved in any constituent occupation. What you also see is that something like only about 10% of these occupations have the vast majority, close to 100%, of the constituent activities that are easy to automate. The other important thing to note on this chart is the fact that something like 60% of occupations have about 30% of their activities that can be automated. That's actually an important point that's often lost. What that point basically says is that many, many more occupations will be complemented by machines than automated away. And that point is often lost in these discussions. It's also important to note that the density of these activities, because we're talking about activities, is much higher in some sectors than others. So as you can see in sectors like manufacturing, there's a high density of these easy to automate tasks, whereas in other sectors, not so much. And this varies, of course, country by country, as you might imagine. Similarly, if you look across the world, you see that the easy to automate tasks are distributed in very interesting ways across different kinds of countries. But I think in some ways the key question, because all we're talking about right now is technical possibility to be able to automate these activities. The key question is, at what pace and how much will this actually translate into automation of actual jobs and work? And what we find is that this question really depends on several factors. And quite often it's easy to focus just on the first factor, which is it technically feasible in some lab somewhere to automate something? We think there are a few other factors that are important to consider. The second one here is the cost of the cost of development and deployment of these technologies. This is particularly important because if you think about, by analogy, something like the electric car. The electric car in the form that we can recognize it today was first demonstrated in the late 60s. But it's taken a very, very long time, mostly because of that second factor, before these things have started to show up on the street. In fact, the first driverless car to drive across the United States, which was a DARPA project, actually happened in the late 80s. And still, driverless cars haven't quite fully showed up yet. So the second point is an important point. The third point, in some ways, may be the most important point, which is how all of this intersects with our labor markets in terms of quality, quantity, and even the wages associated with it, with jobs. And that factor in particular is what mostly drives the differences you will see across sectors and across countries. And that's an important factor. Then, of course, you've got the benefits that go beyond simply labor substitution, as well as social and other regulatory factors you take into account. So when you take all these things into account, where do we end up? Well, as you might imagine, because of these 5 factors, it's very hard to make predictions, and we're not about to make any predictions. So the best that anybody can do is often to think about scenarios for these factors and how they might actually play out. And in the work that we've done, we come to the conclusion that we're not about to face a jobless future, at least not anytime soon. And I'll explain that in a second. In fact, we've come to summarize at least our perspective as jobs lost, jobs gained, and jobs changed. And that's actually quite important because quite often when this conversation comes up, there's overwhelming focus on that first part, the jobs lost, and hardly any discussion about the jobs gained and the jobs changed part of it. So where do each of those pieces come from? Jobs lost. If you build scenarios, as I said, across all these things, in our midpoint scenario, it looks as if by 2030, something like 15% of the global workforce at that point in time could be displaced from automation. And that's a midpoint scenario. And that's 15%, which is close to about 480 million people. That's a big number. And that's important to think about. But let's also think about the jobs gained part of it. So where do the jobs gained come from? The jobs gained come from when we have economic growth and productivity, which often is driven by these technologies, that creates jobs in the economy. We also know that there'll be jobs in the economy that come from the fact that prosperity is rising around the world. There's aging, which is going to create a whole demand for a whole new set of jobs. And we know that we're going to be investing in infrastructure and climate adaptation and a whole bunch of things. That's another source of jobs. But there's actually a third part, which I always find quite interesting, at least the data geek in me, which is quite often a lot of these jobs are jobs we can't even imagine. And in fact, it's actually quite interesting. If you look at, say, the US economy, in every 10-year period, something like 8 to 9% of the occupations in any 10-year period did not exist in the previous 10-year period at all. This is the equivalent, if we had looked in the government statistics in 1995, the occupation called web designer did not exist. But in the 10-year period after that, it did. It was cataloged. So there's a lot of jobs that emerge that we don't know about. So when you put all this into the mix, what do the jobs gained part of this look like? Well, in our estimate, in our midpoint scenario, again, these are scenarios, we estimate that something like about, as much as jobs that can accommodate as much as 21% of the global workforce could be created and gained by 2020, by 2030. So as you can see, we come out ahead, if you like. Now, of course, these are scenarios and they'll vary country by country. And in fact, you can see that with just 3 countries here where we show jobs lost in this midpoint scenario, jobs gained, but also the gray area, which indicates the new people entering the workforce that are going to need to be accommodated by job creation. As you can see, of course, in a country like India, which is a young country, the number of people entering the workforce is a very substantial number. Now, how this plays out country by country, of course, depends on what happens in those countries around economic growth, business dynamism, entrepreneurship, and how the labor markets in that economy actually work. So these are important, these are very, very important considerations. So if in fact, if what I'm trying to tell you is that let's not worry about the jobless future, at least according to our midpoint analysis and scenario here, but can we just sit back and this will all work out? And I think the answer is overwhelmingly no, actually. So even as I don't worry about this jobless future, I do worry about 4 important transitions, and it's worth talking about these. The first one is you can imagine a picture where you've got jobs declining, some occupations declining, and some rising. We know that people are probably going to have to switch occupation categories a lot. From the declining occupations, the growing occupations. We've seen this throughout history. People move from agriculture to manufacturing, from manufacturing to services. But in this case, the occupational shifts are quite important to think about and how we support people as they go through those. Because depending on the pace at which that happens, we may not be prepared to support the adjustments and the transitions associated with that, even if there's enough work for everybody. The second consideration is important, which is the skill shift. We know that as the occupations change, the skill requirements are going to change. The skill requirements are also going to change simply because when people work alongside machines, the kind of skills that they're going to need are also going to be quite different. So the skill shift is the second important transition. A third important transition is the idea of how are we going to redesign work and workplaces to help people work in these environments where they're going to be working alongside machines? That's an important consideration. And then the fourth consideration, of course, has to do with the potential wage effects. And this is particularly important to think about. So these are the four transitions I would urge us to think about if we're going to navigate this well. And you can see this in some of the pictures. This is simply a picture that shows, for a few different countries, some of the occupations that are likely to decline. These are the ones in the orange. Some of the ones that are going to grow that are in the red, and you can see there's quite a shift. You can also see what I pointed out about the skill changes and the skill requirements, starting off very different bases in terms of what skills are going to be in demand and which ones much less so. And similarly, in most simulations that most people have done, is you can already see the effect potentially on wages. And the reason the wage question is important is because many of the occupations that have relatively easy to automate activities have tended to be the ones that have paid middle wage incomes. Think about people working in factories. Whereas many of the occupations that are growing have tended to be occupations as valuable as we may think they are as society, we've tended not to pay for them very well. Think about care work, think about teachers. We value teachers, they're hard to automate, but they've never had great wage structures. So we're going to have to start to think about this. And this is particularly important, and I say this given we have leaders in this room, that in tackling these transitions, we're already starting in a bit of a hole. What I mean by that is, think about the number of times you hear companies tell you they can't find workers that they need with the skills that they need. Think about all the times we complain about how our education systems are already failing us before we've even got to this age we're talking about. Think about the last decade where we've gone through this angst about income inequality and wage stagnation. So we're already starting in a bit of a hole. And maybe just to make the point, hit the point home, this chart shows you, for example, if you look at the OECD, some OECD countries, how much each of these countries spends as a percentage of GDP on on-the-job training, which is on the right, and on the left, which is on the left, and on the right, how much each of these economies spends on active labor supports as people transition from occupation to occupation. What you see is first a varied picture, but more importantly, a trend, which is the investment being going backwards at a time when we think these things are going to be important. So we should think about how we're going to navigate this going forward. So in conclusion, what are some of the imperatives we should think about if this is all going to end up well? I think I'd like to suggest there are at least imperatives of three kinds. The first is one that I might call the deployment challenge, which is how do we make sure that every company, every economy, every part of the world, every society can make use of these tools and get access to these tools in order to get the benefits that come from them. Greg described some of the things that he and his colleagues and others are trying to do to make these available in open source. But is there more we should do? Are there wider investments that companies, that societies, that countries should make to make these tools broadly available? I'll call that the deployment challenge. I think the second challenge is the future work challenge, which is, if we care about these transitions I just described, how do we increase our investments in human capital? How do we deal with these questions to do with wages and impacts? How do we think about redesigning work itself? I think these are very, very important questions, and that's the second challenge I would pose to you as leaders. The final challenge, of course, I would say has to do with how we think about responsible AI. We've already talked and are fully aware of some of the questions that have to do with the uses and misuses of AI. We don't have good enough ethical frameworks, enough questions about privacy and security, and when we should be applying these techniques and how. I think this question of responsible AI is particularly important because if the public loses confidence in these tools and techniques for any host of these reasons, it'll be very difficult to get the benefits of the opportunities that we're talking about and I've tried to describe. So I'll conclude at that point. I'm sure we'll have lots of discussions about this. Thank you.